Guys, we're gonna do 3 notes in the Algebra 2 book. So you should still have that online resource. We should have these. I feel like we copied these in our 1-4 notes maybe. But now we're just kind of working with our angle might not be in quadrant 1 anymore. And then we are going to have to find our r, find the radius of our circle as well. So remember, that's your formula to find our r. And I don't know, I might have to go back to stuff if we forget something. And here's kind of an example as well that you could go to. Okay, and these ones are kind of a little too easy because there's no negatives or positives, but that's okay. So the terminal side of theta and center position contains each point. Find the exact values of the 6 trig functions of theta. So remember that a point is always x, y. So we know these are x and y. So we need to find r. So to find my r, we have 8 squared plus 4 squared. So 8 squared plus 4 squared gives me 80. So we have the square root of 80, and then again, always make sure to break that down. So we'll do 8 and 10, 2 and 4, 2 and 2, 2 and 5. Sorry, you probably can't see that. I'm going to go ahead and write over here. I'll just do 1 and 3. I think that'll be plenty for you guys. So r, I have a pair of 2 and a pair of 2, and then a 5 left over. So r is going to be 4 square root of 5. And then just go through and find your trig functions. So sine theta is y over r, so 4 over 4 square root of 5. Remember, we can't have that, but I'm going to reduce my 4's right away. So multiply by the square root of 5 to the top and the bottom. So sine theta is going to be square root of 5 over 5. And then cosine theta, sorry, this is not organized. Cosine theta is x over r, so x is 8. So we have 8 over 4 square root of 5. Again, we'll get rid of our 5. And I'm also going to reduce this to 2. So we have 2 square root of 5 over 5. And then tangent theta gives me y over x, so 4 over 8, which would just reduce to 1 over 2. And then my next one would be cosecant theta, r over y. So we have 4 square root of 5 over y. So it's just going to give me square root of 5. Secant theta is going to give me r over x. So 4 square root of 5 over 8, which reduces to square root of 5 over 2. And then my last one would be cotangent theta, which is x over y, so 8 over 4, which is 2. Okay. I'll do 3 quick. So again, this is my x and my y. So r would just be 4, how about? Or 2, I don't know. 4 squared, 4. Because you'd have square root of 16, which would be 4. Yeah, so r equals 4. Sorry. So then sine theta is going to give me y over r, so 4 over 4, which gives me 1. Cosine theta gives me x over 4, so 0 over 4, which is 0. Tangent theta is y over x, so 4 over 0. Cannot have 0 in the denominator, so this is undefined. And then we'll go cosecant theta, which is r over y, so 4 over 4, which is uno again. And then secant theta is r over x, so 4 over 0. So again, undefined, because you can't have 0 in the denominator. And then my last one, cotangent theta, is x over y, so 0 over 4, which would give me 0. Hopefully it makes sense. Good. Good. Hopefully. All right. Now you'll want to write this down here. Reference angles. Finding a reference angle. So quadrant 1, that's kind of what we're finding. We're finding a reference angle here. So if it's ever in quadrant 1, you're not going to have a reference angle because that technically is a reference angle. So in quadrant 2, here's the little formulas that we use. So it's just this is in degrees and this is radians. Same thing, but depends if you're given degrees or radians. And then this is quadrant 3. So that's the formula we're going to use. And then quadrant 4. That's what we're going to use there. And again, they are the same thing here. There's not a reference angle in quadrant 1. That's what you find a reference angle in. So first thing, we want to sketch our angle here, and then we want to find its reference angle. So I like to kind of remind myself 0, 90 cents in degrees, 180, 270. So that's telling me that my angle here is somewhere over here. Okay, so that's theta. Now we want to find theta prime. That's my reference angle. So go back up here. Notice we're in quadrant 2. So to find theta prime, we take 180 minus theta, and that's where my theta prime is. Okay, so to find theta prime, we have 180 minus 155 degrees. So theta prime is going to give me 25 degrees. There's that guy. So then that's telling you that this right here is theta prime. Okay, and your theta prime should always be between 0 and 90. That's your reference angle is in between 0 and 90. Okay, if it's not, something went wrong. That is why up here, theta prime and theta are the same thing because it's in quadrant 1. This has to be in quadrant 1. Not necessarily quadrant 1, but 0 to 90, I should say. So then my 230 here, again, we have 0, 90, 180, 270, so it's going to be somewhere in here. So this is theta, okay, but not prime. Gee Louise, just plain theta. So up here, we're in quadrant 3. To find theta prime, this time we take theta minus 180. So here, theta is 230. So theta prime is going to give me 230 minus 180. So 230 minus 180 is going to give me 50 degrees. So this right here is theta prime, which is 50 degrees. Okay. Unless you guys are good with radians, I still don't know radians very well. I like to change mine to degrees and then just make sure you go to draw my angle to know where it's at so that I can use my reference angles up there. And then just make sure you keep your reference angle in radians. So just so that I can sketch it, that's the only reason I'm doing this right now is for the sketch. So 180 times 4 divided by 3 gives me 240. So I'm only using this to sketch this. So again, it's somewhere over here. So this is theta, okay? So then I'm going to go back up here. I'm in quadrant 3 again, but now I'm going to use the bottom because I'm given it in radians. So to find theta prime, you take theta minus pi. So here, theta is 4 pi over 3 minus pi. Now remember, common denominator, so I'm going to multiply this by 3 and this by 3. So we have 4 pi minus 3 pi gives me pi over 3. That's my theta prime. Okay. And then number 4, again, I'm going to change it to degrees just so that I can sketch my angle. And this one is going to give me 330 degrees. So this one is going to be in quadrant 4. So somewhere over here. So this is theta. Sorry, and then this here was theta prime. So now that we drew it, we're going to go back up here. We're in quadrant 4. Again, we're in radians. We're going to use this bottom one. Find theta prime. We're going to take 2 pi minus theta. So minus theta, which is 11 pi over 6. Common denominator, times this by 6, so it's going to turn to 12. 12 pi minus 11 pi is going to give me pi over 6 for theta prime. And that is theta prime. So now this bottom chunk says find the exact value of the trig expression. You'll want to use your, let me grab mine, our sheet that we filled with a bunch of stuff out on. You want to use this guy. I'm going to refer to this a lot because we want to find our reference angles. So if I were you, I would put these on this chart maybe. It's just kind of nice to have everything in one place. Because then we're also going to be using these triangles and then what's positive and what's negative. So first thing, we need to find our reference angle. So 330, that's in quadrant 4. So to find our reference angle, we want to take 2 pi minus theta. 360 minus theta because it gives us in degrees. So 360 minus 330 gives me 30 degrees. So we're going to find tangent of 30 degrees. So that means we are going to use our 30, 60, 90 triangle. So tangent of 30 is opposite over adjacent. So we have 1 over square root of 3, and then we need to fix this guy. So it gives me square root of 3 over 3. Now, and this is quadrant 4, now we need to know is this positive or negative. So in quadrant 4, tangent is negative. So my answer is negative square root of 3 over 3. Okay? And again, guys, here, I would change this to degrees. And you can stay in degrees. Since we're finding here, we're not actually doing this. Once you change it to degrees, I'll work with degrees. It's a lot easier. So 11 times 180 divided by 4. So this is the same as cosine of 495. So subtract 360 because it goes around the circle full time. This is the same as cosine of 135. So now we just need to find the reference angle to 135. So 135 lands in quadrant 2. So that would take, to find our reference angle, we want to take 180 minus 135. So this would be cosine of 45. So use your 45, 45, 90 triangle. Sorry. So here's my 45, 45, 90. Cosine is adjacent over hypotenuse. So 1 over square root of 2. Fix it. So we get square root of 2 over 2. Now quadrant 2, cosine positive or negative. Cosine is negative in quadrant 2. Cotangent of 30, that's great. There's no reference angle. So go straight to your, because this is quadrant 1, this is easy. Go straight to your 30, 60, 90 triangle. So 30. Now cotangent, that is adjacent over opposite. And it's in quadrant 1. Everything's positive in quadrant 1. And then pi over 4, remember that's the same as 45 degrees. Finding cosecant of 45 degrees. So we'll go into your 45, this guy. So instead of, we have hypotenuse over opposite. And it's positive because it's in quadrant 1. Okay. Hopefully, it's not too shabby again. You can use this online book if you need some more resources. But let me know if you have any questions. Alrighty. Miss you guys.